Kind of introduce myself, I guess. My name's Jess Hale. I'm one of the co-organizers of the OKC Analytics group. I'm currently a senior research biostatistician at OUHSC in the Oklahoma Tobacco Research Center. I'm actually about to transition over to working at Ohio State University in the same position, but I'll still be here in Oklahoma, so I don't have to move. Remote work is going to be kind of awesome, I think. And previously I worked in marketing and advertising for a while, and so that was kind of an interesting stint to see both the research side and then also like kind of more of the marketing and advertising world, which very different. And so today we're going to talk a little bit about data cleaning and standardization. So dirty data, I'm sure most everybody has experience with this. If you deal with any sort of data, no matter how much somebody tells you when they've collected it that it's clean, it's likely not. I've never actually received a clean data set from anywhere. And errors in dirty data include things you have duplicate records, incomplete or outdated data, depending on the systems you're getting it from, they may not talk to one another, so they're disparate, and then there's no standardization across them. A lot of times if I'm pulling from two different systems, dates are in a different format, the unique identifiers might not be the same, and so I have to use name and date of birth, and then those aren't even in a standardized format. The list continues. And so really dirty data, they say, is costing the overall industry about $400 billion, which is a lot of money. But if you think about it, when 80% of your time is spent just prepping and cleaning your data, it's not necessarily that hard to understand why that figure is so high. I mean, you have data scientists and analysts having to spend the majority of their time not actually doing analysis, visualizations, modeling, any of it. And a lot of times, dirty data, human error, I don't know if 60% anymore, because I don't know how many, depends on how you define human error, data entry, maybe the form that was built to capture the data wasn't coded properly. Poor interdepartment communication is a huge one I found, especially if you're getting data from different departments. I found this to be a huge barrier because especially if you're working with departments that don't normally play nice with one another, I feel like you end up playing peacekeeper sometimes between them, which is always fun. And then your inadequate data strategy. Again, if you're not having good communication, you're not actually having a unified strategy across departments. So the really big problem is the data silos, right? You get duplicate records, different misspellings of names and addresses. Sometimes people truncate names or have the whole name. Elizabeth may be Liz in another data set, which is a common thing that I've come across. You may have different data formats across the different systems. You may have to hook into a SQL database for one department, but then you'll get CSVs or text files from another. And then a lot of these problems can remain unknown for years. For instance, the current place I'm working at, they had started a study before I got there. It still has probably 3 years to go, and I actually came in, I did a data health check, and come to find out we were missing primary outcomes data, some of the schedule logic was wrong, so many problems. And so I'm glad I found it before we completed this study. And a lot of times, most people are finding out about their problems with their data from a customer or prospect, which is really embarrassing. But if you're not actually checking your data, somebody's going to find it, and usually, it's the customer. So, actually having those regular health checks kind of helps with that. And then a lot of times the process is really manual to find inconsistencies in inaccurate data, and it still kind of is. I mean, they have programs and things you can use, but sometimes it's hard to automate problems you don't know you're going to have. I haven't figured out the right way to do that, to see a crystal ball that says, here's all of the things I need to check for in my data. Just doesn't really happen. So the solution, data governance is a big one. You have to come up with the decision making, the monitoring, and then you have to have somebody that's actually helping enforce that. As somebody who kind of functions in a data management more role, I kind of look to my boss to help do the data governance, because let's face it, when you're working with other teams, you need to have kind of a figurehead backing you up on that, which is sometimes difficult because a lot of times they're like, well, I don't know what you're talking about. You just go do it. But then at the same time, I'm like, they don't really listen to me because I'm not the figurehead of it. So it can be a little bit challenging at times, but hopefully you can find somebody within your organization that you're at that can be your kind of data governing individual, or hopefully multiple people. Documentation is something that just doesn't happen often enough, I think, with data. Dictionaries are a huge thing that people, I don't really think, focus on putting together, and not just a good data dictionary. One that has, okay, here's my variable names, here's the question that's actually getting asked, here's the formats, here's the min-max values, here's the branching logic applied to this question. You need to have all of that, but very few people actually put together that robust of a data dictionary. And then communication, it's kind of a common theme. I think that's where most problems just kind of break down, is people just don't communicate. A lot of times whenever, especially in marketing, when I was brought on, they hadn't really had a data and analytics department. And they're like, well, I didn't think you needed to know this information. I was like, no, tell me everything. Just give me all the information. Don't worry about overwhelming me. Like, I'll be able to use that. That's kind of a common thing I get told is, you don't need to know, that's not relevant. But then when I'm able to go through about 10 to 15 reasons why it's relevant, they start to understand. So when you get data, what's a really good starting point? I've always found that I start with kind of a general analysis plan, even for just data cleaning, because I need to kind of map out my steps a little bit. So really you have to ask yourself, what's the what, the how, and the when. So the what was the purpose of the data that you're supposed to be cleaning and analyzing? What were the questions they were trying to answer? What's the bottom line of this? What's the specific population? I've gotten data sets and I get no information on what is supposed to be my denominator. Like, is it patients? Is it, groups of people? Is it a product? Is it a customer? Like, what is it? You need them to define that for you. And then the formatting. What's the data set type? Is it multiple CSVs, text files, server? Like, what are you getting? And then is the format in wide versus long? I don't know if anybody else has this problem, but I tend to get data sets in both ways, to where, wide's where it's usually a single record with all the data in a row, and long is repeated, which I wish I could just get it in one format. Personally, I prefer long, because I think it's a little bit easier to go from long to wide. When it's wide, especially if you have kind of repeated data you're getting, they usually put like a number at the end of the record. So you may have info 1, info 2, info 3, info 4, info 5, but it's the same variable created, captured multiple times. And then you have to tell it, oh, well, I want this to now be its own variable repeated 5 times. So it's personally long's the way to go if you can get it. The how, this is really what tools are available to you. These are the common ones. These are the ones that I have a tendency to use. SAS is my heaviest used one. Trying to migrate more into R and Python a little bit, especially for making data visualizations and dashboards. I know Tableau's kind of come up a lot for, I think they have like kind of a data cleaning tool that you can get. I haven't really messed around with it yet, but I've heard that it's good. People like it, so I've been meaning to try it out. Who doesn't like to dabble in new programs, right? Tableau Prep, that's what it is.
It's cool.
Is it good?
Yeah.
I've been meaning, because I'm not a point and click person. I like to write my code because I like to know what's going on. So that's been a hard transition. That's why I've just never been a hardcore Tableau user. Even with like Power BI, I still do all my data cleaning in like SAS or R or Python, and then I put it into one of the tools. But I'm trying to get better at it, because I'm finding a lot of places really want you to have that Tableau skill or some sort of dashboarding tool skill. And a lot of times, Power BI is their desktop version. Tableau, I think, has a free desktop version you can get. So you can still learn about it. Even if you're not able to get a paid version, you can still play around with it. And then the how is, another how is, what's the final format you need to give it back to somebody in? Do you need to dump it back into somebody's database, and what's the structure of that database? Would be nice to know, so you actually get them the right file. Because I always hate knowing I gave somebody a file and they tell me they had to do stuff to it, and they can't tell me what they did. And then they say they have errors, and I'm like, well, I kind of have to know what you did to it to know where something went wrong. Either I did something wrong or they did. So having those discussions up front are really nice. And then if they need a wide or long format, for me, I have a tendency to have to put something from long to wide for researchers, because a lot of people use SPSS at OU because that's what researchers like. It's point and click. But they like their data in a wide format versus long. For some reason, I find it more complicated. But making sure you talk to people about what they want the data structure to be like. The when is probably one of the most important things, and one of the pieces I, for a long time, neglected all the time, and I shouldn't have. I learned the hard way, was to actually figure out when they wanted the data set by. People would tell me, I want it ASAP, and I would just try and get that thing done ASAP, but then I had about 5 other ASAP things on my list, and then I couldn't prioritize, I couldn't figure out timelines very well, and so really asking them, okay, ASAP is defined as what? Like, is it a week? Is it 2 weeks? What's the turnaround time? Like, really establishing that and pushing them to do it. They'll still just want to tell you ASAP, but try not to give in. Most times they don't balk at it. They actually are like, okay, and then you can kind of list out all the other things you got going on, and you're like, I can't get this to you if you don't tell me a time. So from there, developing a timeline for that person, I've really noticed that breaking it out for somebody of how long this is gonna take me based on what their goals are, but also incorporating the time I think it's gonna take me to do it. That's the thing I don't always do. Like, I take the time that the timeline they give me, but then I don't incorporate the time that I need as much. Because just because they want it in a week doesn't mean I can actually give it to them in a week, realistically. So I haven't really figured out the best equation to deliver a timeline, because depending on how many variables you have, how many data sets, that kind of comes into consideration, but I always tend to give a range and sometimes make it really wide just so I can cover myself. Like, honestly, I don't think it's out of the question to actually tell somebody this may take me 10 to 15 hours. I don't think it's bad to give somebody a range and say, here's all the reasons why, and then just keeping them updated as you go. That's another thing I found to be helpful, is giving people updates, because a lot of times if it's going to take you a while, especially when somebody doesn't understand, they're like, why can't you just give this to me now? It's just a simple, I just need this subset of the data and I need it cleaned. It's like, well, if it was that simple, can you do it? Is tending to be what I ask them, a little bit more diplomatically, but I do tend to just say, if it's so easy, then can you tell me how I should do this then? Do you have an idea of another approach I can use? And usually they just say, okay, never mind, you do it. And so once you have your analysis plan kind of worked out, you need to look at the levels of measurement for all the variables in your data set. If you're lucky enough to have that wonderful, robust data dictionary, you don't have to go through as much of this, but 9 times out of 10, you may not always have all the information you need. So typically when you get data, you have two primary types. You have your categorical and then you have your continuous. In your categorical, you have the nominal type, so like your race and marital status. You could have dichotomous variables, and then you have your ordinal. I find it really important to distinguish those, because a lot of times in data dictionaries, they don't tell you when the data was collected, if they intended it to be an ordinal versus a nominal piece of variable. And so then order does matter typically to people in the ordinal sense. So getting that distinguishing information is really helpful when you're putting it together. And then you have your continuous. So this is where you have intervals. And you don't have exact zeros with intervals. So a great example is like temperature. You can have a temperature of 0. There's not really an end value to an interval. And then you have your ratios, where you do actually have a true 0, so things like height, weight, duration, there can actually be a 0 point. Another piece that I found useful, we do this a lot in research, but I also applied it when I was doing marketing and advertising, is defining them as independent versus dependent variables. So your deep independent variables are the ones you kind of use as predictors, and so you kind of control those. Like in research, you define the population you're collecting data on. So you define their ages, the gender groups, the treatment groups you're assigning them to. Those are your kind of independent variables. Then you have the dependent side. So these are kind of like your outcomes, changes in response to the independent variables. So it'd be like in research, we have a lot of lab values. We look at typical tobacco biomarkers, NNAL, cotinine, those sort of things. But then the flip side of that is in like marketing and advertising. It could be, do people click on the ad? How much product did they buy? How much did they spend? And either of these can be continuous or categorical. It kind of depends. So actually defining that I found to be really helpful, because then I know how to structure the data a little bit better, knowing how they want to analyze that data and how they intended it to be used. Because if you ever get to a point that you have to analyze the data you cleaned, knowing this information is really helpful for modeling purposes. And so some programs that people typically use, SAS, R, Python, I just kind of broke out like similarities or differences between them. SAS is a very procedure-based language, so you have a lot of procs that you use. There's proc import, proc content, proc freak, just very heavy in that way. R and Python are more object-oriented languages, so really migrating from SAS to R or Python can be a little bit challenging. Great thing is there's tons of resources out there, so if you're ever trying to migrate between one or the other, there's usually somebody out there that's come up with if you do it this way in Python, here's how you do it in R or SAS. SAS is not case sensitive, but the other two are, that's a hard transition, let me tell you, because I'm just used to being able, I don't have to worry about if something's capitalized or if my data set has, if the different pieces have capitalizations in them, I can just type it in all lowercase and I'm fine. But in R or Python, that's not the case, which is hard sometimes when you're just trying to get something done because you couldn't do it in SAS. In SAS, data sets are known as data frames in R and Python, which is kind of nice because there's similarities a lot between R and Python. Variables are columns in the other two, observations are rows. Whenever you want to group variables, you do a by group, but then in the other two you do group bys, and then how they define missing is different across the three. I thought this was kind of interesting that each of them did that a little bit differently, how they natively define that. So knowing this information before you go into starting your data cleaning process is really helpful, especially if you're more well-versed in one tool versus another. I'm just going to show you a couple of outputs. SAS is kind of across 3 slides because they put out a lot of output. It's a habit they have. So this is proc content. So this actually gives you just a general idea of what's in your data set, right? So this is just the first box it gives you, tells you your data set name, when it was created, modified, how many observations, how many variables, pretty basic information that you'd want to know. This one, I've never really used this information that much, but it gives you the page size, number of data set pages, those sort of things. Again, I don't really find this page as useful, but then kind of the meat and potatoes of it is this slide. And so this actually has, you have your number, which is the variable order it appears in the data set, so which column it's in. Then you have your variable name, the type, and so in SAS they define it as a number or a character, and then you have the length, and then the format. So the formats are really nice because in SAS a lot of times people will apply actual formats that they've created to the variable itself. So actually seeing, okay, what format was applied to that. So like for manufacturer, it has a character format of 1. I always check when that happens because 9 times out of 10, it didn't read in the variable correctly because there was probably a lot of missing rows in that particular column and data didn't exist till row 50. And so it just assumes there's nothing in that actual column, but there actually is. And so sometimes you have to check your data that it was imported correctly, especially in SAS. In R, I use the string function, and so this gives you some of the exact same information, how many observations, how many variables, all of the list of variables, the type it is. I thought it was interesting how it did, the factor is for the character value, and then you have an integer or a number for your continuous type variable. So I thought this was also kind of nice because it gave you an idea of some of the values that exist within each of those variable types. And then Python, I use the info function. I'm still learning how to talk between these languages. This gives you some of the same information. I think that this gives you the least amount though, because in the R one, it actually gave you some of the values that you were supposed to get or that were in your data set, and this doesn't.
Is R the same way?
No, R gives you, so R actually has, after it tells you how many levels, yeah, it actually kind of gives you at least an idea of what's in them. So you can tell if it's supposed to be a character value, do I have everything I need? The type here is one, the third one down. You see that it has factor with 3 levels, and there's CH, and then missing, and then it gives you 222. So that, tells me I probably want to look at that variable a little bit and see what's going on with it. But yeah, and there's ways that you can get some of the, like you can print like the first 10 rows or something of your data if you want in all of these programs. But I was trying to figure out like something that was similar across all three that just gives me a general snapshot of here's what I got. So that was the best I could find across the three. I'm a SAS user, so I found SAS, of course, to be the easiest and the quickest because I just do proc contents, tell it what the data set is, and I hit run. And it gives me all that information. And then I had to dig around a little bit more in R and Python to find something I exactly wanted. So once you know what's in your data set, this is where you start doing what people call like, descriptive stats. So what's actually in there? So from the overall standpoint, exploring your data by the sampling group is something that I found, when I work with other analysts, a lot of people approach it as they just look at the overall data set, but if you're supposed to be grouping these by something specific, like for research, we usually have people assigned to different treatment groups. So you may have treatment group A, B, and C. Actually breaking out your descriptive stats in that way is really helpful because then you may see some discrepancies or inconsistencies across how your data was collected, especially if you have any sort of branching logic or things like that in any of the data collection process. When they're categorical, actually looking at your category values, I found a lot of times if people are supposed to be, like if it's an open text field, but people are supposed to be entering in very specific values in there, they're never consistent. Some people type in all caps, lowercase, proper case, all kinds of things. So actually checking your category values to make sure those are good. Frequency counts are a big one for categorical. I mean, that's mostly what you can do on it. And then checking your missing. This is a big one for categorical because I found that like in the data set I'm looking at right now and I'm trying to clean, there's several variables that branch off of another one and they're missing because the people were never asked that question because how they responded to the first one, but they shouldn't actually be missing. They need to be coded to no. And so there's things like that when you're doing your categorical variables and you have like that, if you have a really good data dictionary with branching logic, because a lot of times people think when you say data dictionary, you just want variable names, their values, the type, min, max, and that's it. It's like, no, I want the actual, any sort of branching or logic you've put on that variable. For a continuous, the total n that you have, how many are missing, your mean, median, mode, your kind of typical kind of continuous things you look at. Quantiles are a big one that I tend to do because dependent upon where the distribution falls for a continuous variable, we would perform some transformation on the data, and so knowing where things are distributed on the quantile side is really good, and then the standard deviation, which is the variability of your sample around the mean. So this is an example of doing more of a categorical variable in SAS. So you use procfreq, it gives you the actual values, then you have your frequency, percent, cumulative frequency, and cumulative percent. It takes out the missing, so it's not included in your totals, but in SAS you can put it back in by telling it you want to include the missing in your overall count. So say you have a variable that has 500 total observations, but 145 of them are missing. If you want to know like what's that percent missing without having to hand calculate, you can make it to where it includes it in this actual table and gives you that information. R, I use the library question R for this one, and it kind of gives you some of the same information you get from SAS. I found that the missing just didn't have a value in it, which I thought was a little odd. I need to check back and see because I downloaded this serial data file and I didn't get to spend as much time looking through it on the raw side, but I thought it was interesting it actually included it in this frequency table, but it gives you like your n's, your percent, and like your cumulatives, which is nice. And then in Python, they have crosstabs. I couldn't really find one that included the percents very easily because what I try to do is take the approach, if I had to turn around something really quickly, I need to be able to find a solution fast. So I tried to spend less than 5 minutes trying to find the solution in R Python as I was going through this. And so this was the one that I found was the best in Python. I did find that as far as creating these type of tables and everything in Python to get all the information I wanted in it was somewhat challenging to get everything in one table like I can say in SAS. But of course, SAS is something you pay a lot of money for, so I will say there is a free version that they have, that university edition you can download, so you can at least teach yourself SAS and use it for like personal use if you want, which is nice to have. And then, okay, so you've done your descriptive stats. Now you have to do your recoding of values. For categorical, this is where you look for like your spelling errors. Case of values is a big one that I find. Acceptable code values, making sure everything matches. Like, do you have a value that's in there that you weren't supposed to based off of your data dictionary or your formats? So you essentially, you find, you clean, and manipulate. That's kind of a cyclic process that I found. For continuous, that's where you do all your range checks. Hopefully in your data dictionary, they told you what your min and max is supposed to be. A lot of times, they don't normally do that. What I found when I do continuous variables and then I give somebody this information, they're like, oh man, this is too high of a range. This isn't supposed to be in there. It's like, I asked you before what your min-max values were and you said that there weren't any. But now that we're looking at it, you're telling me there were. So I always tend to, if that comes up, just educate people a little bit that, this is what I was asking for when we started the process, when you made the request. Looking at calculation checks for continuous variables, so if any variable is based off an equation somebody else did, check it and get the equation they used, because I probably find 60 to 70% of the time there's something wrong with the equation. And that's how I get missing information. Like, we actually had a experience recently where somebody had formatted a value incorrectly for us to do minimization, randomization, and it's not good. Luckily, we can rebalance it. That's what's nice about when you do minimization, randomization, but nobody actually went in and checked any of these things. They just put it in there and they didn't check it against the minimization app, and it was a problem. So making sure you check calculated fields. I know that it seems time consuming, but literally I think it's saved me so much time, because for the research that we do, our calculated fields are actually used as part of our primary outcomes. And I don't really want to end up doing analysis on a calculated field that is wrong. And also visually inspecting the data, so doing histograms, box plots. I love box plots. I think they're great. I think it's a great way to visually see where your data's at. I love the box too, because it kind of shows you the range and everything. So visually inspecting it, and also, depending on your requester, showing them that information, it can sometimes be a little overwhelming, but I find that teaching people about some of these things and actually taking them through it is so helpful, especially if you keep getting requests from the same people, and it will make life so much easier if you can get them to kind of grasp and understand underlying concepts. So missing. Everybody deals with it. This is the part that I think is the most horrible about cleaning data. And you have 3 primary types of missing data that you can have in a data set. So you have missing at random. This is missing based on other data. So like my example where you have branching logic that causes somebody to not be asked that question, that's kind of missing at random. You can't tell when that variable is going to be missing, but you can fix it based on how they answered previous questions. You just have to know that that's there. You have missing completely at random, so there's no pattern with this. You can't figure out why it's missing at all. And then you have missing not at random. This is the one I tend to always forget to check. So this is where, say you're asking a question that's sensitive. Like, big one is drug use, right? So we ask questions about people's illicit drug use. If you check that variable against, say, some of your demographic information, you find that males 18 to 30 are missing that data 80% of the time, but then all the other subsets are only missing it 15 to 20, that's not missing at random. That group purposely didn't answer that question. So you may actually want to keep that as a value in your analysis, because it's meaningful based on that group. So actually kind of checking those things a little bit, especially if you have variables with high missingness, is really great. But again, this one's kind of always the one I tend to forget about, but I'm trying to incorporate it a little bit more. Let's see. So the next one is when you have missing for categorical. For this piece, you got to check how your variables are coded. For categorical, I found that a lot of people put either NA or NAN, or they just leave it blank. That's been another one. But then in the continuous side, they'll leave it blank, or sometimes I'll have people put 999 or 777. But the worst part is when you have other continuous fields that actually have that value and it's valid. Run across this all the time. I've started asking people just to leave it blank, to be honest. It just makes it so much easier because they're not really thinking of the fact that they've created 10 other variables where you could actually have a value that's the one they assign for missing. And I just try to encourage people, it's like, please just leave it blank if you can, or especially for continuous, because you can't assign it a categorical value, right, in your continuous data set. So for me, it's easier if they just leave it missing. Now, categorical-wise, bless you. I do find it useful if they try to assign an NA or an NAN. Like we had a recent example where we were having participants try certain products, and if the participant didn't want to try it, they were just leaving it blank. And then there was another group of people that they were marking it as 0 because they didn't want to leave it blank. Because they were like, oh, no, we wanted to make sure you had values in there. And I said, but no. Please don't put arbitrary data in there, because 0 actually had a meaning already. It meant that they didn't like it, but they thought they should put something in there. So there's a lot of education even on your data. Anybody who's helping with data collection, I've been trying to do a lot more of this because I've found so many times where there's these patterns that just don't make any sense. And that's where I know, and that's how I found out they were putting zeros. And I was like, just leave it blank. So I've had to start putting all these field notes and everything else, but really checking with people on how they defined missing is very helpful. And then, are the missing values valid? To that same point, it's like for that example I just gave, a missing value was actually valid, right? For if they didn't try the product, they should have been leaving it blank. I could actually take people that missed that showed up for their visit and create a new category, didn't want to try product. And so that's a whole different category I can add. So again, really talking with the team who's done this to make sure you incorporate any logic that they have. Again, the branching logic, are these questions branched off of something else? We ask smoking status a lot, and it's kind of on a scale. So we first ask, have they smoked in the last 30 days? If they say no, we don't ask the 7-day or 24-hour, but those should now be no's, not missing, so on and so forth. So those, just things like that are nice to know. Sometimes you don't always know. And then for the missing and continuous, again, checking the calculated fields. If you're getting a field that's based off an equation and you got a lot of missing for it, the calculation's probably wrong. I found that happens a lot of times because somebody did something wrong in it. And so I always check to make sure if it's a calculated field. And also, was your data pre-coded before you getting it? I always ask people, please don't try to clean it for me. Just if I have to get it from somebody else, I'm like, just dump it. Please don't touch it. They try to be really helpful, and I'm like, I appreciate your effort, but please just dump it in the rawest format possible, because I always find the missing piece is the thing that they try to help with, and they usually end up making it worse. No fault of theirs, but that always tends to be the piece that I've noticed. So I always ask people, did you do anything to the data before you gave it to me? And you have to be very careful when that happens, because you don't want people to think that you don't appreciate their effort. But again, I find if I sit down and I kind of show them why, it tends to go a little bit smoother than just saying, don't touch it. But messing with humans is always tricky business, right? So the next piece with missing is how you handle them. So this is always the fun part, because depending on who you're working with, they may want to talk to you about it, they may not. They may just say, you just do whatever you feel like you should do. There are so many options for missing data. So for, a lot of times for categorical or continuous, you can do what they call list-wise deletion. So you just take them out. You don't even keep them in. Most of the time people take this approach. Where I work right now, we can't do that because of many reasons. Again, you got to make sure you examine it on a case-by-case basis, calculation, branching logic, all of that. Maybe you add a missing indicator, so you just group everything into a missing group if it is a categorical variable, or if it's a continuous, you assign it a fixed value. In this case, since you're handling this, you can actually make sure it's a value that's not a valid value across multiple fields, which is nice. And then you can do single value imputation. We tend to do this a lot. And so this is where you can either take the mean score of a variable. You can do this somewhat with like ordinal and nominal variables. So if you have a scale of disagree to agree, and you know it's 1, 2, 3, 4, 5, you can still take the mean of that and give that score to like a person if you need to, because typically at the end of the day, even if something's on nominal, we tend to do mean scores. So that's one way you can impute, or you do what we call last value carried forward. So depending on if you have what we call repeated measures data, so a lot of our studies, we have one that has 8 visits. Lots of people don't make all of their visits, but say I have data missing for the 2nd visit and data missing for the 5th. For certain variables, what we tend to do is we take what they said at the previous visit and move it over to the current. Because depending on how far the range is between visits, I will say that caveat, you could likely impute that value and their feelings maybe haven't changed. Because we ask a lot of, we do a lot of psychological based research, so we ask a lot of people about their feelings about something. And a lot of our visits are grouped within 1 month, week at a time, but then we go out to 12 weeks, 26, and 52. If somebody missed their 12-week, some of the questions, I wouldn't want to impute I wouldn't want to do last value carry forward from 4-week. That's too far. So making sure you're kind of incorporating that when you're deciding which way to take. Another thing you can do is what they call sensitivity analyses. So you take either the worst or best case scenario. So you replace with the highest or lowest observed value. Doesn't really work on scales like nominal or ordinal, but on continuous variables, you could use this method. Another one is multiple imputation. It's somewhat of a pain. It is very cumbersome. It's the method a lot of people are starting to migrate towards because you take multiple independent variables to impute that missing. You create data sets that are imputed, and then you combine the results from each, and then you impute that value. It's a very, very time-consuming process. And depending on who you're working with, and if you have a lot of missing data, it's the way to go. If you have way too much, and I would go that route, but if it's kind of random within it, and it's not terribly consistent, single value imputation is sweet and easy, and it tends to do the job. The other piece is outliers. I don't know how many people actually have to look at this. A lot of times when people request it, they don't even think so, that they even need to worry about it. But marketing's a big one. Even I found people are like, I don't care. It's like, but if you have one person that spent $50,000 and the next person below that only spent $5,000, that's going to really skew your data a little bit. So we might want to take care of that when we're actually running models or making, I don't know, graphs and figures, because then your scale is huge. Sometimes they understand. Sometimes they still want to see it, which I haven't figured out why, because it makes no sense to me from a budgetary standpoint. But for outliers, you can either remove them from the data set, which is what a lot of people do, because they just don't want it to skew their analyses. But depending on how many outliers you have, you may not want to do that. So a lot of people will cap the data, so that way any values, say above the certain point, they are all assigned to like, say, 5,000. So in my previous example, somebody had 50,000, but the next highest was 5,000, you just cap that person at 5, and you keep them there. You could assign a new value using the imputation methods that you also use for missing, or you can do different methods of transformation. There are so many options out there that you can do. These 3 are the most common that people do. So a log transformation, you take the log of each observation, so you kind of normalize it and standardize it, but then you can back transform it. The reason why we tend to do this a lot is whenever we're reporting results for models, we want them to be on the same scale that the variable originally was. So for a lot of our lab values, do this with a lot of biological data, you have to transform it, or it's not normally distributed for you to run your models on, because that's one of the assumptions. But when you report the data, if the value is like 0.5, but the range of that lab value is usually, say, 10 to 20, that's not really meaningful or interpretable to readers or to your reviewer, say your reviewers in a journal. So we have to back transform it back onto the actual scale. So there's ways to do that in case anybody runs into that. You can do the square root, same thing, you take the square root, bat transform it by squaring it, and then Windsorization has been one that I find I like a lot. So this is where you limit the extreme values, and so you set all outliers to a specific percentile. It's almost like capping it in a way, but what you do is you tell it that I want to cap it at the 90% mark. So if you do that, you would see all the data below the 5th and above the 95th set to the 90, like to that percentile. That's where it caps it for you. So there's ways you could do it on both extreme ends. There's ways in SAS where I found some macros that do this for you. I haven't really looked into this as much as in R or Python, but I find it's probably one of the cleaner ways to transform it, because the log transformation in square root, you still have to back transform it, and that's trying to explain that to a researcher that doesn't do stats or analysis is kind of difficult, to be honest. So I'm finding I'm taking the Windsorization route more often. The last piece that I tend to check on is duplicates, because you've just gone through all this data cleaning, right? I used to do this first, but then I found when I started to analyze it, I saw something funky. I was like, oh, what happened? And it was usually because during my recoating and cleaning process, I might have done something within that where I created inadvertently something that was a duplicate that shouldn't be. So I've started actually checking for duplicates at the end. I sometimes still do it at the beginning, but I found duplicates at the end is kind of the cleaner way to go. So this is where you have the presence of one record means the other is not required. So you can have kind of two types, more than one record ID exactly for the same data, or what they call partial duplicate. So this is where you have more than one record associated with the same observation. So we found this happens, like, say there's dyads or teams of people we have, and that means we're only supposed to have two, but then all of a sudden I find 3 people have the same dyad number. Well, that's a problem. Where'd that third person come in? In this instance, I found out that one of the people decided to drop out after the first visit and then was replaced by this other dyad, or this other person to be part of the same dyad. And I was like, okay, did somebody like catalog this somewhere for me? So as you're going through it, you know what happened. And so what you really have to do is make sure people define duplicate for your data set, because depending on how you're looking at it, you may find duplicates that are truly supposed to be there. So if you just do it, say, by the unique identifier, if you have repeated measures data, you're gonna have duplicates because they have multiple measurements. So you don't just wanna do it by the ID. So you really have to have somebody help you define what are those variables to identify the duplicates. And so you have to check, the number. A lot of things that I check for on duplicates is how many values are missing, the range of them, how well they represent the data. The lack of quality has been a big one, because I found in our data a lot of times I'll have the same time point for 2 people, but the dates are different. What happened was the person came in for their first visit, had an issue, and came in for their second one, and basically repeated the visit. So I no longer needed the first record for that time point. And how I discovered that was I noticed all of a sudden their data stopped being collected. So there's a way, and I can share this paper with you guys, where you set kind of cutoff thresholds based on how similar 2 records are to one another, and you can actually assign a value, and it will help you go through this process, especially if you have a lot of identifiers that you need to find duplicates based off of. And kind of, I guess this is kind of the final piece, is the data checkpoints. So if you have a lot of dates, you need, making sure, is my data collected within the right time period? I find so many times, if you can keep people from having to enter in a date for you and have it auto-captured by the system, go that route. We've had people like where we have to send them surveys, and we ask them, I was like, please put in today's date. And they put in their birthday. All the time, it's always their birthday. I don't know why. Thankfully on the system end, I capture when that field was created, but I don't know why, and we even put not your birthday right there underneath it, and people still do their birthday. So trying to really make it to where dates can be auto-captured is a godsend. And then whenever you're checking your data, do they fall outside or within the time period you're supposed to be looking at it? on the flip side, I find that there's a lot of data entry errors. A lot of our people are putting 2018 still instead of 2019, which has been very problematic because we have data that was collected in 2018. So because we have repeated measures, I then check what's the time, how many days are between this visit and this visit? And whenever I find a negative, I'm like, okay, somebody did something wrong here. And that's what I've been finding a lot. So that's another way, just kind of checking it. Transposition's a big one that I find a lot. So some people may do 1920 instead of 2019. Lots of crazy things. And then data collection time points. So for instance, when we do repeated measures, when we have like 5 time points, do I actually have data for all 5 of those time points? That's a great way to just kind of check at the very end that it's nice and clean. It's another way to see, you know, are your participants, do they have all your time periods? There was a study that I inherited data for without a lot of information, and I didn't realize until I looked at the data this way that there was a subset that only had 3 visits and another subset that had 5. But because at the very end I went ahead and did it by like time point, I noticed, oh, what's going on here? So I went and asked the coordinator, the person who was kind of managing it, what happened. And so it's just kind of a nice final way to package it. And that's the end. Thank you. Sorry. I was hoping to have some more like actual coding examples to go through. I'm still working on that. My university edition is not cooperating. I will say if you ever do try to use university edition, it is very cantankerous. Like you can't really update it, so you may have to re-download it, but the nice part is if you have, you know, Python use Jupyter Notebook, you can put all your examples like in the same library and kind of save them that way. So I am working on kind of going through and showing how to do each of these pieces in all 3. Because I think that would be really handy. Even personally, and I think other people would like it, because that's one thing I couldn't really find is something that showed me these really kind of hardcore, like these basic pieces that you always need to do, but nothing really described how I could do it across all 3 of them. So I am working on that and hope to share that with you guys after this transition's done, hopefully, and then, you know, maybe take people through that at a different meetup or something too. Does anybody have any questions?
What does NAN mean? I've seen the name, but I've never seen NAN.
I can't, what? Oh, what does NAN mean? Not, oh yeah, not a number. There we go, thank you. I was like, no. Oh yes, pandas, sorry. I keep forgetting, like, depending on where you're at, like in what library you're using, it always switches it on you.
Did you find any drop in the number of people who submitted their birthday address, including the word birthday in the description?
So did we see a drop in people including their birthday when we actually added it into the description for the variable? That is a no. I don't know why, but when you do data entry forms, even if you add what they call like field notes or descriptions, people do not read those. They do not. So depending on the type of data you're getting, if it's survey data, getting as much of it via interview form, I think is helpful, but then also having like checks in place. So one of the things we started doing within our system is we added like a check form at the very end that piped information into it so that our data collectors could see kind of a report at the very end without having to go through each form, because we have about 30 different instruments we collect at a given visit, which is a lot to go through. So we did kind of an aggregated one at the end so they could kind of fix it. But with dates, if you just need somebody, especially just to put the date that they're filling it out on, figuring out a way to auto capture that and hiding it so that they don't see it is the only way to prevent that. Even just having that text, nobody reads it. I don't know why. I haven't figured out why. We even made it bigger, bolded it, everything. Yeah, it's like nothing. I don't know why. Mm-hmm. Mhm. So for running analysis, the question is, what if your data isn't normalized, and how do you approach that? Depending on the types of analysis that somebody wants to do, you can use non-normalized data, so there's non-parametric and parametric tests. And really you just have to look at the assumptions of the model that perhaps they're wanting you to use for the analysis and go from there. But I found that a lot of times, like, the Windsorization method tends to really help evenly distribute that data, but I always do the normalization after I standardize everything, is what I tend to do. So I standardize first, so I check for usually missing, outliers, all of that, and then I standardize it after the fact. And so that tends to be helpful, but again, it depends on the method of analyses they want you to use, because there's a certain, the non-parametric, and I believe I'm saying this right, you don't have to meet the assumptions of a normal distribution to run those models, but a parametric you do. But a lot of these systems can allow you to run both, and you can do the same types of models. So it just depends. Does that answer your question? Okay, how do I describe parametric and non-parametric tests? Oof. I mean, I think the biggest difference between them is the fact that the assumptions are different for running them. So running the models. So parametric tests have a lot more assumptions you need to meet, like there's homoscedasticity, I can never say that word, normal distribution, those sort of things. And so it kind of just depends. Like logistic regression typically is, if you can be a parametric test, but then like in SAS, you can run logistic regression using parametric methods versus non-parametric methods. So there's different procedures that breaks them out. And I don't know if Pandas is the same way. I haven't tried with it, but you usually can do models within both systems.
You said 30% of males do not fill in.
Oh, well, that was an example. Possibly. I've never really looked into it personally. What I tend to do is if I see it's missing for a subset, I just have a tendency to create that as my own variable. Big ones that they have, I guess they do have published research on, like income is a big one that a lot of people don't like to talk about or put on there, especially depending on if they're a high or low income. We see those missing a lot for groups. And then if you're asking about, say, people in rehab or drug use, those are always big ones that tend to be missing for certain subgroups that they found. They just said that's just kind of human nature, like people are embarrassed or they don't want anybody to know. Even if you tell them it's, anonymous, they still have a tendency not to. And from there, that's how you know, okay, I need to actually put these as their own group. Because you'd want to see, is that group of, say, males 18 to 30 different from everybody else in my sample? So when you're running models and things like that, you can include the gender variable, the age variable, and that outcome variable to see, do they drastically differ? And you can even look on multiple, like, kind of fields and variables to see. And that even of itself is a key finding. So that's what we do. Lots of different avenues to take. It just kind of depends on the person you're working with. Like for us, for research, from one study, we can publish 20, 50 papers off of the data we collect, because one of the studies we're running right now collects, over time, we have 50 different surveys. And so, yeah, there's a lot of papers that just can be written off of subsets of that data. So I've started always checking for that missing not at random piece, just because, it's a key finding if you find people.
Have you ever dealt with surveys that you take input points in time?
Mm-hmm.
And then when you do them, nobody something disappears. You shouldn't throw it all out.
No, we don't throw it all out. A lot of times, depending on the model that you're running, it can handle missingness. So when you do analysis, just making sure you read up on the analysis technique you want to use, then that it handles that missingness appropriately. And so most of the time, models these days, they've been able to incorporate the ability to handle it so that you don't actually have to dump them out. Or you can do the imputation as well. So if you, for some reason, if somebody wants to run a model that doesn't handle missingness, that's when you can look at, say, multiple imputation or last value carried forward for that. So you can actually fill in that data. We have a tendency to see people just not generally filling out pockets of the survey because they get survey fatigue. That's a big one that we've noticed. From there, that's when we have a tendency to just do that last value carried forward. But if somebody misses a whole visit, that's where we have to make sure, do we need to impute this? Or we need to make sure our analysis method, like the model, can actually account for that and handle it appropriately. Because it can adjust and everything, and it assigns scores on the back end for you and stuff. So just, yeah. A lot of times, like on SAS's end, if you look up a particular procedure you want to use, it will break down all of that information for you, like all the assumptions, what it can handle and not handle, things like that. Because when you sometimes run models, you need to do dummy coding. So in SPSS, you actually have to manually do that, but SAS handles that for you natively within its program, which is fantastic. Saves you a ton of time because dummy coding is, I don't know if anybody's done dummy coding, it's god-awful. It's the worst thing because you essentially have to create almost different groupings of the different combinations of the, yeah. I like doing it using SAS for that just because you don't have to actually do it manually. Any other questions?